Okie dokie. Good. All right, everyone. I hate to be the last one to stand between you and the end of the conference, but here I am. So my name is Michael Ludden. I work for a company called Terso. We are a database company. We make a distributed database based on SQLite, and I am here today to present to you about why you should give every one of your users their own individual database and how that could even be possible. So I couldn't, this is a late addition, the Oprah meme, but it's just too perfect for this, so I figured I'd get it in for what it's worth. Everybody gets a database. Okay. We're going to talk a little bit about OLAP versus OLTP. That's the nerdiest thing we're going to do. And then we're going to talk about all the bits about multi-tenancy, why, how, what, do a brief architecture comparison, and we'll get you out of here. How does that all sound? All right, cool. First of all, does anybody know does anybody know about OLAP? Who knows about OLAP? Kinda, yeah? Okay, I'm not gonna make you tell me what you think it is, but feel free to correct me if I'm wrong. Who knows about OLTP? Okay, most of you, I think, even though only some of you raised your hands, actually know about OLTP. You just think you don't because you have no reason to understand the acronym. So let's start with OLAP. OLAP stands for Online Analytical Processing. Yes, the L is line in online, which is interesting. OLAP is a type of database technology that is about long queries. It's not latency sensitive or throughput sensitive. It is throughput sensitive, and it's mostly for business intelligence. So essentially, it's for analytical workloads. Workloads that are long running, involve large chunks of data, and that aren't optimized for latency. So not great for multi-tenancy and the use cases that we're going to discuss today. These are some companies that offer OLAP processes. So you may have heard of MotherDuck, probably Redshift, ClickHouse is another one. We're pretty familiar with MotherDuck. I recommend any of these if you're interested in analytical workloads from a database perspective. That's not what we do at Terso. We do OLTP, online transaction processing. So this is shorter queries. Latency is kind of the whole deal. How fast can we return the result to you? It is also throughput sensitive. And just think about using it via API. That's how a lot of people commonly consume it. Essentially, it's for transactional workloads where you're trying to scan as little data as possible. You're making the query as short-lived as possible, and you're achieving the lowest latency as possible for better user experience to your end users. Most popular database offerings you're familiar with are OLTP. If you use a database for anything other than analytics, it's probably OLTP. So most Postgres databases, for example, are OLTP. So, for example, think of a user profile with a user ID, and you want to fetch only the data associated with that ID. That's always going to be OLTP. It's never going to be OLAP. If it is, you're doing it wrong. So this is us. This is what Terso does. We're going to talk about these things today and why and how multi-tenancy can actually help you lean into what OLTP is supposed to deliver. Yeah, okay. So modern OLTP needs. Aside from the technical aspects, there's a lot of compliance and privacy considerations that you have to take into account, especially when you're talking about data related to a specific person, such as patient data or credit card purchase history, or if you're dealing with regulatory environments like GDPR. In the US, we don't have any of that, so it's just kind of a free-for-all. But a lot of us build modern distributed applications that function in multiple regions, including ones with a higher degree of user protection for their citizens. So in the case of GDPR, you might need to be able to, does everyone know what GDPR is? It's like the European compliance law. Yeah, okay. You might need to be able to purge records from existence upon request in certain regulatory environments like GDPR. That's just one example of how your OLTP solution needs to be compliant in ways that it didn't used to be back in the day. The more isolated the data is, the better, obviously. The less opportunity you have to screw up and accidentally do something illegal that could get you in trouble. So what is multi-tenancy? We'll go through this briefly. Actually, I think this isn't brief. So Multi-tenancy is offering, for the purpose of this talk, multi-tenancy can mean a lot of different things depending on the scenario you're describing it in. In fact, when we first started thinking about this, and you would Google multi-tenant, it could either mean, depending on the definition, and I don't want to confuse anybody here, it's just kind of a funny thing. It could either mean a SaaS in which there are multiple tenants for a single database, or a SaaS where it's got multiple users and each one has their own databases. So like it could mean the thing or the opposite thing. It's very confusing. But I think the industry is kind of aligning on the idea that this is, at least in the database world, this is offering a database per tenant instead of partitioning a giant database, slicing it up and saying this part's for this tenant, this part's for that tenant, and having kind of a granular accessing and permissioning system for that. You're probably familiar with that architecture. That's pretty much still the standard. But in this case, what I mean by tenant is really any way you want to divvy it up. If it's per user, per region, workspace, agentic query, which we're all starting to be familiar with, hospital, patient, session, could be any unit that you want to divide it by. That's what a tenant means. And multi-tenant just means, yeah. So anyway, why multi-tenancy? It is an easier path to compliance in many ways. So if you have per user isolation saying each user has their own database, and let's say you need to suddenly delete all data related to the user to comply with GDPR, you just delete their database. And there's not going to be any issue with accidentally deleting multiple databases or contamination of what you're trying to do there. If a user's asking for a copy of their data, you just literally copy the database and give it to them. In the case of SQLite, that's very easy because SQLite is literally just a file. So a SQLite database is just a file. You copy it, give it to them, there they go. Just makes it very simple from an architecture perspective. Per user encryption. So if you need to make sure that the data is extremely secure and you want to do individual keys on a per user basis, you can do that, and it's much easier than using one database that houses all user information and trying to differentiate user keys and managing a very granular permission system there. Why multi-tenancy? Another reason, you may all have felt this at one time or another, developer velocity. It increases when mistakes cost less. Mistakes in shared resources can multiply the cost by the team size, and a shared database is often a source of terror, dare I say. You can mistakenly query or update or delete unrelated user data much more easily because the data is not as isolated as if literally every user has their own database. So why multi-tenancy? I feel like I'm going through this fast, but I do have a lot of slides, and I was trying to go through it fast. Anyway, we'll see. If we have time, we'll have questions at the end. Replication. So another reason for why multi-tenancy is replication. Independent replication is hard to do with a big centralized database. It's easy to do with a fleet of small databases. You can just replicate one database or two or three or however many you need. Developers can work on replica DBs of a user data, so just copy this, edit it, and that can be independently hosted wherever you want, on a mobile device, using API services or in a microservice each if you want. And if you have slow queries, no one else gets defended. The noisy neighbor problem goes away. There's also huge latency advantages to replication. Terso is a file-based database. As I said, it's based on SQLite. So there's no separate server required to be running. It's embedded locally in your app, and that means you can serve queries in microseconds, not milliseconds, from a local file system with absolutely zero network latency. There's no egress that you have to deal with. That's more impactful than most of the other optimizations you can actually do in software. It's just sort of an architectural benefit that's simple. Another reason why multi-tenancy, simplicity. So there's no need for row-level security in many situations, which can be a real pain. Has anyone here ever dealt with row-level security in a SaaS? Okay. Is it a pain? Okay. I saw some nodding. Okay, cool. I mean, it's not cool. So here you go. So there's no need for caching with replication. You can actually replicate to a mobile device, complete with offline writes. We just introduced that from a platform perspective. So you can actually have a local replica on your phone, write to it. And well, I guess caching would be more about replication. So anyway, you can read from it as well. Per user backups and restore. So a whole class of problems related to user rollback of data are now solved with a single operation. So it's much easier to roll back an individual user's data if there's some issue than it otherwise would be. Another reason why multi-tenancy, and this may be counterintuitive, this is kind of the whole point of the talk, it's actually potentially extremely cost efficient. We hear a lot, isn't it expensive to offer thousands or eventually millions of databases like that? And I think it's great that we get this question a lot because it means people are very ambitious. And I think a lot of people always think that their service is going to be eventually serving millions of users. And a lot of times that isn't the case, but even if it is, it's not an issue. So because Terso is based on SQLite, it's just a file, it's infinitely scalable, and the cost is very efficient. On our free tier, we offer 500 databases for free just to start and play around with. And by the way, I'm kind of using per tenant and per user interchangeably, but the per user thing is just a type of tenant that I think makes a lot of sense to people, right? If you're thinking about a user-based SaaS and you want to give each user their own database. So forgive me if I'm using them interchangeably. You can think of other types of tenants. I already gave examples, but it's just easy to think about like, okay, you start an offering and you have your first 500 users using it. Well, you can do that on our free tier very easily. And then all the way up to unlimited databases by the time you get to our pro plan, which is still a self-service plan. So you're never going to be receiving some sort of surprise billing because, oops, you got 1 million users and now that's going to cost you an insane amount because you have to pay for all those databases. It's practically free, unlimited databases when you think about the cost structure not being based on how many databases you have as much. So let's do it. You can just use a SQL database, and this is just in general. This isn't related to Terso necessarily. You can just pick a boundary that shards naturally, so like a user, a customer, a page. That's talking about the tenant of it all, and make the application aware of it. And then every unit, which is like a tenant or a user, can just be a SQL database. So how can this effectively scale other than just being a file, right? So this is the usage expectation that people have when they think about how people are going to, I guess, hit the database, right? Query the database. And this is the usage reality. I think most people who've ever tried to do a SaaS product have experienced this. You have a few users that cost a lot because there's just tons of usage, and then most users use it very little. But you end up having to pay for all of it to keep the database up and running all the time, just in case, so that nobody has a horrific experience. So you have to have a long-running server, whether there are requests or not. Scale to zero does partially solve this, but users can keep you from getting to zero if they make as few as, or cause as few as 10 queries a day. So it's kind of only a partial solution. So how can we solve this? SQLite is the solution. It is the most memory efficient database on Earth. It's designed to run in constrained environments. Every one of your devices that you have on you has many thousands, I'm pretty confident, of SQLite databases inside of all the different applications that you run every day. Every mobile phone leverages SQLite because it's meant to be running in a constrained environment. And SQLite's already been used in traditional multi-tenant architectures for a very long time, even before sort of the modern era of distributed computing. Being that it's designed to run, and what do I mean by it's designed to run in constrained environments? So it comes with memory limit controls, cache size, has a heap limit on functions. You can actually determine what that limit's going to be and adjust it. Same thing with CPU limit controls. So it's much easier to just kind of dial up and dial down how many resources it's going to take to be running in a given moment. And with all that, it's still incredibly capacitive. So you can have over 200 terabytes of storage, over 2,000 writes per second, and over 100,000 reads per second on a single SQLite database. And we're talking about hundreds, thousands, tens of thousands. That's pretty good. And we forked SQLite because it wasn't good enough. And we made libSQL. So libSQL is our SQLite compatible fork that adds things like replication, things that modern applications need, right? SQLite was always thought of as an embedded database, like I said, that's on your device, but it's not something that you would use in a serverless environment, right? So libsql and Terso on top of that solves for that. With libsql itself, it's fully open source. It's also open contribution, which is something that SQLite itself is famously not. And we would love a star. We got to about 12,000 stars recently. It's a vanity metric, but if you feel so inclined, feel free to go to tur.so/libsql, give us a star. We added replication, backup and recovery, encryption at rest. It's also accessible over HTTP, which enables the whole serverless managed offering aspect of it. And we also recently added vector embeddings support. So instead of using a separate vector database, like Pinecone or Chroma for a lot of use cases, if you're just trying to do vector search or on-device RAG, or just RAG in general, for AI purposes, you can actually just use a column type, which is vector embeddings, right within the same libsql file, and do it right there in a very lightweight way. So talking about architecture, Terso is fully isolated. If you think of the client being the application as querying the data over HTTP, each request can be completely unique and, boy, I wrote that wrong. I don't even know what I meant by that. Memory and CPU. Got two in my head about that. Anyway, you can secure that with anything you want in terms of like encrypted keys, JOT, or anything else. And then idle databases cost zero, again, because it's just a file. So you can also use Terso just like you would any other modern serverless database offering, and you can get one of the simplest, fastest developer experiences out there. I put this slide in there because I think we're talking a lot about alternate architectures and different ways of thinking about this, and that could give you the impression that when people sign up for Terso, it's like really difficult to comprehend. There is not a big cognitive lift. You can literally just start with a database. A lot of our users just use one database. You don't have to do multi-tenancy. We talk about a lot of different interesting things you can do with Terso and that it does enable. But you can start with the simplest possible use case. And the other aspect of it is the local development story with Terso is probably one of the simplest ways to get started building an application with a database, because you can literally just have an on-device SQLite file, and then when you're ready, just switch out the driver, and then boom, you're accessing it via the managed service. So it's actually very simple to get started. I don't want to scare anybody off with all this kind of talk of flipping the apple cart over. Pricing is also really generous. I mean, you can see here that it's a very generous free tier. We get told that all the time, but it's also pretty cost-effective to get things like databases that never sleep, crazy higher limitations if you need them, multi-region replication up to 10 locations, and unlimited databases. All right, so that's enough. That's almost enough promotion. So if you're interested in trying Terso, use this coupon code. You'll get 10% off any of our paid plans for a year. But again, I just encourage everybody to try it out. We have a Discord. We've got quite a few people on. It's very active, and we would love anyone to join that wants to. It's right there on our website. I forgot to put the link here, but the team is extremely responsive all the way up to the CEO and our CTO. And if anybody ever has questions, it's not like we gate support to only paying users. So we've got a good community there, and I encourage you to join that. But that is, wow, I burned through that way faster than I thought I would. That is the talk, and I have a few minutes for questions. If anybody has any questions, thank you. Cheers. Yes, sir. I saw that hand.
Many databases and you need database migrations.
Mm-hmm. How do migrations work is something that I can't speak to, but I know that there is a good answer to it. So database migrations, I think there's like, I don't want to misspeak. SQLite solves for that, and I think there's like a triple digit. No, in fact, sorry. We have something called, if you're talking about multi-tenancy, we have something called a schema database. So you can have a schema database that defines the schema for all of your multi-tenant child databases. So let's say you have a SaaS and you're using the databases to store like user information, but oops, you forgot the field where there's like an address, right? And you want to add that, but you don't want to have to add it to every single database manually, obviously. because let's just say you have thousands of customers. You can use the schema database to just add it there, and it will add it to all the databases. So I actually did have an answer there. Next question. If there is any, maybe there aren't any. I thought I saw one more hand. Somebody get scared off? Come on, there's got to be one more question, and then I'll be done. How's that? Yes, sir. Wherever you want. So where does the SQLite file? What's that? No. So the SQLite file itself can be. So we're on AWS and we're on Fly. So it can either be on AWS and we do that on S3, or it can be in a fly.io location, or you can literally embed it inside your application. Yeah, and by inside your application, that means like on device, if your application is living on a mobile device or on a server somewhere, or on-prem, if you want to do it in your server at home, right? Sorry, just one more thing. Regionally speaking, on Fly, there are 34 locations, I think, that they have all around the world. And on AWS, I think we have 4 regions spun up at the moment, and we're adding more. Oh, yes? Yeah, typical scenario would be that the multi-tenant applications would be stored in the cloud and the client accesses it. The client could also be in the cloud, right? Or the client could be local on device. Typically, yeah. Although we just introduced offline rights, so technically now the database can be local or on device. But yeah, typically they're in the cloud. Oh, yeah, yes. Sorry? Reliance. Compliance. Oh, compliance. Okay. How secure are we? Yeah, HIPAA data, right. We are HIPAA compliant. We went through SOC 2 a while ago, so we're SOC 2 certified. So in terms of how compliant are we, as much as we possibly can be. Yes. Yeah. Yeah. How do you handle authentication on each of the databases? It depends, right? I mean, we recommend you can use a third-party auth provider of your choosing. We haven't layered on an auth layer ourselves onto the platform. We have been asked that a few times by people who come from like Supabase and who just don't want to mess with third-party auth. I think right now we're writing a few guides on how to do this, and I think we've already put some stuff out there as well, where it's like easy buttons to just get that going if people don't just want something that works for auth. But typically we recommend third-party solution of your choosing. One alternative to that is you can, like, I think I had it on an earlier slide. Let me see. You can, where did that go? You can use JOT tokens, encryption keys, or you were probably asking about more like, actual like fine-grained auth solutions. Yeah, yeah. Cool. All right. Thank you guys so much. I'll let you get out of here. Thanks for staying for my talk. Appreciate it.